It just got some technical error, so just stopped in the half. So I'm just continuing that with a new video. So what I'm saying is, like 2D materials. Uh, 2D materials we cannot go. 2D materials, I don't know how much we could go with the 2D materials. I mean, of course, we have to explore the new ways because that's how the system works, right? When new innovation comes, so we have to find new ways, new materials, new kind of thing. That's why I love material science much more in recent days, not recent days, but I just have much more interest in the basic science stuff like chemistry also, because of no, I just give a much more respect to STEM, math, science, everything like much more. Uh, how can I say engineering, like much more respect. I already had respect from my childhood, but just keep going up because of whatever you take to innovate or break things into the pieces, you just end up there, or it will come to math and science and chemistry, engineering, technology, all those sort of things just combine. You cannot take one and like you cannot think out of that. It's hard. So where did I left the argument? Where did I left the argument? I'm just guessing where did I left the argument, and I just lost. So yeah, they say hybrid challenge. It could work side by side to the traditional CPU and GPUs. I think which might be a good thought in the first. But as I asked in the previous videos, how they're going to keep up with the speed of, I mean, speed not speed of the quantum computing or photonics will come up with new chips, and how will the classical computing going to keep up with those things? It's a huge question. I think someone has to answer for me. uh, I'm not being arrogant or something like that. I just have a few questions in my mind I could give out of thinking, and I'm just coming up with these things. So I just explore different materials, and later I will share like there's a one AI. When people say AI, is that people using AI for like a hard task? If you ask, is that they're using that for the hard task, like a task that which is matter, which will improve the innovations and science kind of thing, which will help us to solve the hardest problem. Like when I look, just a few companies just be able to successfully find a new materials in that sense. So it's like it's not a waste in full sense, but it's like sometimes it can get you near to the new materials, finding new materials. So something like that could so happen. So what I'm saying is like using AI, many people right now try using AI in the EDA tools, synopsis, cadence, and everyone is doing that, and I'm so proud of that because you know that AI should solve that other than just making random memes. I'm not against memes. I love memes. You can see that in my X page. I love memes. So I'm not against memes. What I'm trying to say is we have to uh, we have to just use those capacity, that much power to use full task, other than just we are wasting time with the AI making the videos that is not useful, like mocking someone or some kind of sometimes it's funny, but it's good, it's cool entertainment. But I'm saying I think you get the point that we need to use that for the useful task. So uh, when uh, when integrating with, that's the challenge I have with the integration, like quantum computing. People say like integrate quantum computing with the classical computing, that's how it can survive. But again, the same question I already told that, right? So I'm sure I limit. So but there's another thing like a it is, I say the waveguides modulators, like if you could make a smaller one, dense one, like if you could pack much more waveguides and modulators and directors in one place, you can increase the speed, which is cool. So I wonder like how they're going to do that. I mean, is that also will face the similar fate the transistors face? I mean, of course, when we go beyond one certain limit, we could face quantum level problems. There's a huge problems, like we couldn't find a solution for that, like for that. So however it's going to face some kind of a challenge at some point. But I'm asking like for 15 next 15 years, is that will survive? Is that the the amount we are going to make smaller, will it survive that much for the humanity's competing eras? So it's like a hard question for that. And so I'm saying like natural limit light as well, and usually which much larger than electron features. Yeah, another challenge is 1 micrometer. which is light's wavelength, and electron is nanometer. Shrink for components is yes, this is important, right? You can't shrink photonic components as easily as transistor. This makes dense putting billions of photon rays on a chip extremely hard. Yes, this is why I said the photonic computing companies, startups will get the funding up to $120 million. Still find hard to bring that to market because it's hard. I know hard. That's why I want to do that. Yeah, just okay. I'm just saying. I just love complex thing, and if it's easy, what's the point of doing that kind of a my own logic system working in that way? So forget about that. So what I'm saying is 2D materials and metamaterials. Of course, the metamaterials. I just went into the whole companies just working with metamaterials and 2D materials for a long time, and I just have to share about those things also. So metamaterials, how light interact with those things, and how they create like atom, like an artificial atom molecule with that is kind of an interesting thing too. So I just asked these questions, and they said that is only possible in the math, which is I wonder more like how to say that, but I wonder which is uh, when we make something like a like a 3D 4D dimensional, if we come back to 2D, it's like going up and down. 1D, what is minus 1D minus 2D, going to be like that, and they said it's only accessible in the math, and in math means it's like in the imaginary world it's possible but not in the real world. So it's like kind of a stuck. It's again we are going to for the foundation of the physics, right? The foundation, the founding theory. So I always say that everything is connected and everything is just keeping you your heart. You will feel the sadness. So it's not the right thing to do. The plasmonic mixed photons with surface electrons release wavelengths. Surface electrons okay, yeah. Um, I know they're approaching this with yeah, every time they find a struggle, they're going to mix that with the classical things. That's what plasmonic and 2D materials and metamaterials is going to do that. So not really. Yes, I just went into the like whole optic system, like how it works and all. So I think I could say that about that in the next video. So I need some rest.